All right, welcome to this explainer on Agent Smith. Today, we're diving into a system that is fundamentally changing how developers interact with local AI. We spend a massive amount of time talking about the AI's mind, obsessing over parameter counts and benchmark scores. But here's the reality. The secret to truly autonomous coding isn't just a smarter mind, it's a better architectural body. But before we get into the solution, we need to talk about a universal developer frustration. We've all been there, right? You ask an AI chatbot to edit a file in a massive code base. You paste in the code, the AI confidently spits out an update, you paste it back, and then you realize it completely lost the context. Line numbers drifted, some random chunk of your config file just silently vanished into thin air. The AI is sitting there proudly declaring success, but your app instantly crashes on startup. It's just a probabilistic mess. So let's contrast that standard AI chat, which, let's be honest, is usually just a thin wrapper around an LLM that gives up early, loses context, and breaks your files, with Agent Smith. Agent Smith tackles this by wrapping local AI models in a rigid, deterministic harness. Instead of just chatting back and forth, it gives the AI real, tangible tools, persistent memory, automated verification, and instant rollback capabilities. So what exactly is Agent Smith in plain English? Basically, it's a local-first desktop AI coding assistant. Think of it like a heavy-duty cockpit that lets smaller, local models, like maybe an Ollama instance or Qwen running right on your own hardware, actually work on real projects. It takes what would normally just be a text box chatbot and turns it into an actual coding partner by giving it a highly structured environment, strict guardrails, and real access to your file system. The user experience is broken down into 3 distinct modes, which is great because it lets you scale the AI's autonomy depending on what you need. First, you have chat mode for your standard, safe conversations. Second is agent mode, where it acts as a local operator. It can use shell commands, read files, and browse the web, but always within strict guardrails. And finally, there's code mode, which is the full-on automated build pipeline. Section 1. The automated build pipeline. So, diving into code mode, here is exactly how that automated pipeline actually works. You hand it a build or repair ticket. First, Agent Smith explores the project to get its bearings. Then, it creates a structured plan, literally writing plan.md and implement.md files right to your disk. After that, it starts making controlled edits. Once the edits are done, it runs your commands, lints the code, runs your tests, and even does browser checks. But the absolute game changer here is step 5, completion gates. These gates strictly prevent the model from claiming premature success. It literally cannot tell you, "I'm done," until the code actually compiles and the tests pass. And the way it navigates complex project hierarchies without getting totally lost is through structured planning and persistent memory artifacts. It uses these action flow trees to map out its exact path from the starting state to the goal. So instead of that blind trial and error where an LLM gets stuck in an endless loop, it relies on these saved artifacts to know exactly where it is in the workflow at all times. This is what actually keeps a local model on track during a massive multi-file refactor. Section 2. Inside the harness architecture. Okay, let's pop the hood and look at the heavy-duty engineering making this all possible. Picture a dark mode, Matrix-inspired desktop cockpit that actively manages every single move the AI tries to make. The system relies on a few core components. You've got an Electron desktop shell and a main process engine orchestrating code mode. But the real magic? That's in the tool executor. This layer safely allows the AI to read, patch, write, and grep files. It's the absolute hard boundary between the AI's probabilistic guesses and your actual hard drive, ensuring it only touches your code through highly controlled, verified tools. Plus, there's a robust plugin system so you can extend the harness with custom tools whenever you need to. Now, to understand why this tool executor is so crucial, just look at the benchmark data on file editing strategies. Naive AI wrappers usually default to atomic writes. They just rewrite the whole file. That suffers massively from the lost in the middle problem, where your code silently disappears, and frankly, it costs a fortune in tokens. Sequential editing isn't much better. It suffers from line drift. Agent Smith's harness, on the other hand, relies on precise script and unified diff editing strategies. It uses patching tools that keep the raw file content out of the main token window. It's vastly faster, way cheaper, and entirely reversible. And speaking of reversible, you've got to see the change ledger because the harness is the one in control, not the LLM. Every single edit is snapshotted. You get this live tool timeline. If the AI makes a dumb mistake or goes down a total rabbit hole, you are always in control. You just visually inspect the diffs and hit revert all instantly. You are literally never left untangling a massive mess that the AI made in the background. But you might be wondering, what if the AI goes completely rogue? Well, that brings us to deterministic guardrails. You just can't trust an LLM to guard another LLM, right? That's like asking the fox to guard the henhouse. So instead, the harness uses pure zero-dependency pattern matching to block dangerous actions. If the agent hallucinates and tries to run rm-rf/ or attempts path traversal to scrape sensitive cloud metadata, the guardrails will hard block it in less than 2 milliseconds. No questions asked. Which leads us perfectly to this quote, which is essentially the central thesis of our explainer today. The model is only one part of the system. The harness is what makes the model useful. By surrounding a smaller, local model with a rigid structure, verified tools, persistent memory, and hard deterministic safety nets, it transforms from a basic, chatty text generator into a hyper-competent coding partner.
It really does completely change the paradigm of AI development, removing from just talking to an AI to managing an automated worker. Knowing that you can finally have deterministic safety, instant rollbacks, and code that doesn't just silently vanish, are you ready to let a structured, local-first harness finish your next pull request? Agent Smith is built entirely for local AI, real tools, verified work, and developer control. Thanks so much for joining me on this explainer, and happy coding.